Assalamualaikum and hi. So this is chapter 4, which is polynomials. So in this chapter, we're going to learn about these 4 subtopics, which are the first one, polynomials itself. The second one will be remainder theorem. The third one will be factor theorem. And the last one will be roots and zeros of polynomial. So we're going to first see what is the polynomials itself. Okay, so for the first subtopic, polynomials, this is the learning outcomes. So at the end of this lesson, you should be able to define polynomials and state the degree of polynomial and the leading coefficient. So you have two new terms there, the degree of polynomial and also the leading coefficient. And then second one, you will be able to recognize monomials, binomials, and also trinomials. The third one, you also should be able to perform addition, subtraction, and multiplication of polynomials. And last but not least, you should be able to perform division of polynomials and write the answer in the form of px, p over here represent polynomial, equal to qx times dx plus rx. So what is qx? Qx is quotient, d is divisor, and r is the remainder. Later on we will see what the detail for this equation. Okay, so for the introduction, you have seen all these basic functions before. Okay, all these 4 functions you have learned about this before. So for the first one, fx equal to b. So this b can be any number or can be any constant. Okay, for example 1, 2, 3 and so on and so forth. So it can be a constant. So this function is actually known as a constant function. Okay, then the second one, you have fx equal to ax plus b, where a must not be equal to 0. Okay, so meaning that your a should be start from 1, 2, 3 or any negative number as long as it cannot be 0. So you will this function will be known as linear function. Why is it linear function? Because you only have x over there. Okay, ax plus b, where b is the constant. The third function, fx equal to ax squared plus bx plus c, where a must not be equal to 0. We call this as quadratic function. Okay, so you have learned this quadratic function in the previous chapter. Okay, why this is known as quadratic? Because you have square over here. Okay, and the last one, fx equal to ax cubed plus bx squared plus dx plus d. So this is known as a cubic function. Cubic means you have to the power of 3 over here. You have power of 3. Cubic function. So all these functions are special cases of the general class of function, which we call as polynomial functions. Okay, so kesemua ni kita kenali sebagai polynomial function. Okay, walaupun dia berbeza, ada yang constant, ada yang linear, quadratic and cubic. So this is what we call as polynomial. Okay, so it's not really a new thing for you. You actually have saw this and you actually have learned this polynomial before. It's just that you didn't really recognize that is actually polynomial. Okay, you dah pernah belajar, cuma you tak perasan that one is actually polynomial. So for today, you have learned that all these function, constant, linear, quadratic, cubic, and so on and so forth belong to polynomial functions. Okay, let's see the definition. A polynomial, or usually denoted as P, capital Px of degree n is defined as Px equal to, dia kata dekat sini, sebuah polinomial Px tu dengan degree n maksudnya dia punya ni lah, dekat sini kan kuasa n tu, kita boleh define sebagai this equation. Px equal to anx to the power of n and then plus an minus 1, dia getting decrease the n minus 1 already. Sini n, then it become n minus 1 until lah dia become 0. Okay, so sama juga with the n over here. So you have n minus 1. Okay, the power or the degree is getting decreased. And the an over here, or what we call as the coefficient, ataupun kita panggil sebagai perkali, an ni must not be equal to 0. Okay, where n is a subset of integer, positive integer. So z over here, z over here, z plus over here is what we call as positive integer. I believe you have learned what is positive integer in the first chapter, right? Okay, so dia kata dekat sini, n ni actually mestilah belong kepada positive integer. What is positive integer? Start with 1, 2, 3 and so on so forth lah. So dia tidak boleh kuasa negatif dekat atas ni. Dia mesti kuasa n ni mesti sentiasa positif. Okay. And A0, A1, A2 up until AN are called as the coefficient of the polynomial. So, sebutan A dekat sini, we have A, and A dekat sini. Semua ni kita kenali sebagai coefficient of the polynomial. O perkali untuk polynomial tersebut. Okay, so don't worry, the equation seems long, nampak panjang, but as long as you can understand what is this P, what is this A, what is this N belong to, you are good to go for the next lesson. Okay, so again, P, capital P over here denote our polynomial. All A over here in this equation are our coefficient, perkali. Okay, and the N over here, power ni, ataupun kita panggil sebagai dia punya degree. Degree untuk this X must be belong to positive integer. So, kalau dia kuasa negatif, maksudnya itu bukan polynomial sudah. Okay, when this n become negative, then we won't consider that as a polynomial. So it must be positive integer for the n. Then you can say it is a polynomial. Okay, note that the coefficient of the highest power of x, an, is the leading coefficient. Okay. Okay, dia kata dekat sini, the coefficient of the highest power of x, perkali untuk power x, kuasa x yang tertinggi, itu adalah kita kenali sebagai perkali terunggul ataupun perkali leading coefficient. Leading coefficient lah, perkali terunggul ataupun perkali yang utama. Okay, nanti kita akan tengok untuk lebih detail. Mungkin when you read it in this word, it's quite wordy, macam it's hard to understand. But later on, we will see the equation. Okay, and the constant term is A0. Kalau ada dekat belakang sekali, contoh dekat sini, A0 ni, yang dah belakang ni kita dah panggil as constant. So that become the constant term. Okay, the third one, the degree of the polynomial is determined by the highest power of x. Okay, dia kata degree of the polynomial tu kita tengok, kita tentukan dengan melihat kepada apa power yang tertinggi untuk X tu. Okay, so kita ada all these three specific things that you need to understand. Okay, so don't worry. Let's see the example of polynomial function so that you can get a clear picture of what we have just now. Okay, so for example, over here we have polynomial equal to -7. Px equal to -7. So, apa kita panggil ni tadi? Apa nama function dia ni? Apa nama, apa nama, what we call this one? Px equal to -7. We only have constant over here. Okay, so this is what we call as the name of the function is constant function. Okay, what is the degree? So how do we determine the degree? You need to find X. Do we have X over here? Ada tidak X dalam sebutan ni? Tidak ada kan? So the X is actually, no, we don't have X. So the degree is 0. Okay. So what is the leading coefficient? Apa tu leading coefficient? Leading coefficient kita kata tadi, kalau kita ada X macam ni, leading coefficient dia adalah yang di depan dia tu. So in this polynomial, we don't have X, right kan? We don't have X. So of course we don't have leading coefficient. That's why the leading coefficient here is 0. Okay, how about constant term? Okay, so macam saya kata tadi, the constant term will be the one at the end, yang paling hujung. The last term. That is the constant term. Yang tiada X. The one without X. So this is without X, right? So automatically we call this as the constant term. So we write it down. The constant term is actually -7. Okay. How about this second polynomial? We have 5x minus 6. Okay. 5x minus 6. Okay. What is the degree? Okay, now to determine the degree, you have to look back at your X. So here, your X is actually to the power of 1, right? To the power of 1. Okay, let me jot down a bit. Okay, you have X over here. So this X is to the power of 1. Okay, so that's why your degree become 1. Okay, what function is this? We have 5x minus 6. Okay, when you have degree to the power of 1, this one we call as linear function. And what is the leading coefficient? Okay, macam mana kita cari leading coefficient is that you cari you punya x yang dengan kuasa yang paling tinggi dan cari apa perkali dia. Okay, so in here you have X find X with the highest degree. So X with the highest degree is this one. What is the leading coefficient? The coefficient at the front. So the leading coefficient will be 5. Okay, over here. And how about the constant term? Okay, the constant term is the one without any X. So this is the constant term, -6. Okay, I hope you have a better picture or clear picture about what is degree, what is the name of the function, the leading coefficient, and the constant term. Okay, we move on to the next example. You have 7x squared plus x. So the degree over here is 2. The degree is 2. Okay, and when you have degree 2, the name of the function will become quadratic. And what is the leading coefficient? Leading coefficient meaning you have to find the x with the highest degree or the highest power. So ni x ni yang paling tinggi dia punya kuasa adalah 2. And you refer back, what is the coefficient? The coefficient is 7. So we choose leading coefficient is 7. We don't choose the leading coefficient 1. Dekat sini kita ada 1 kan? We don't choose 1. Why? Because x is over here is not the highest power. The highest power belong to here, x to the power of 2. That's why we choose 7 is the leading coefficient. And how about the constant term? Do we have constant term over here? No, we don't have any number at the back. That's why the constant term become 0. And for this one, 2x cubed minus square root of 7x squared plus x plus 3. So the degree is 3 over here. And this function we call as cubic function. So the leading coefficient will be 2. Leading coefficient sekali lagi, saya ingatkan, pekali utama ataupun leading coefficient ni kita cari dengan cara you find the highest power of x. Bila you dah dapat the highest power of x, you refer back what is the coefficient pekali di depannya. So the pekali di depannya adalah 2. Okay, so you have 2 as the leading coefficient. And how about the constant? Constant is 3. Okay, and the last one, x to the power of 4. So the degree is 4. And the name of this function kuasa 4. Selalunya kita tengok up until cubic kuasa 3. Ni ada kuasa 4. So this power to the power of 4 kita panggil sebagai quartic. Quartic function. And the leading coefficient will be 1. Dekat sini ada 1, sorry. Let me erase. Okay, so the leading coefficient 1. Kenapa 1? So kita ada x to the power of 4 pekali dia adalah 1. Okay. And the constant term is 5. Okay. So I hope you have better picture after all these examples of what is degree, what is the leading coefficient, what is constant. Now we better move to the next examples. Okay, examples of non-polynomial expression. Okay, sebelum ni kita dah tengok apa tu polynomial. But how to differentiate whether this is polynomial, this is non-polynomial. So senang sahaja how to determine whether this is polynomial or non-polynomial. Okay, we refer to the power. Kuasa dia dekat sini. You have x to the power of 1 over 3. So what is this? 1 over 3. It in term of fraction, not in positive integer. Integer tadi kan yang nombor bulat kan? Positive integer, nombor bulat. 1, 2, 3 and so on and so forth. But not in term of fraction. Bukan dalam bentuk pecahan like this. So this is obviously not non-polynomial. Bukan polynomial dah, this one. And let's see for this one. We have 3x to the power of negative 1. Dia dah kata negative 1. This is totally wrong. I mean, this is totally not non-polynomial. Kenapa? Because the power is negative 1. Remember, syarat untuk dia jadi polynomial, the power over here must belong to positive integer. Apa tu positive integer? Nombor bulat 1, 2, 3, 4, 5, 6, 7, 8 and so on so forth. Okay? Tidak boleh negatif. Kalau ada negatif dekat situ, dalam bentuk pecahan, also non-polynomial. Sama juga untuk this one. Ini x square. Walaupun dekat sini dia positive integer, but then dia ada square root. So square root ni, kalau kita tulis dalam bentuk, dalam erti kata lain, this square root, dia become x to the power of 1 over 2. Okay? So we have x to the power of 1 over 2, which is actually quite similar to this. Okay, lebih kurang macam ni lah. Power dia fraction. So this one cannot be polynomial. As same goes to this expression because we have negative and also negative. So these are the examples of non-polynomial. Okay, let's move to monomials, binomials, and trinomials. Ada banyak dah. Mono, bino, trinomials. Okay, polynomials with one term kita panggil sebagai monomial. Kalau dia ada satu term saja macam ni, kita panggil sebagai monomial. Kalau dia ada two terms maksudnya ada x kuasa 3, ada juga sebutan x dekat sini. So, this is we call binomial. How about trinomial? Trinomial mean you have three terms. You have terms over here. Ada 3 sebutan. 1, 2, 3. So you have 3 terms. Okay? That's why it become trinomial. Sorry. Okay? So monomial ada satu sebutan. Only one term. Binomial you have 2 term. Okay? Trinomial you have 1, 2, and 3 terms. Okay? Okay, now since you have better picture about polynomial, we can what we can do with polynomial, we can perform algebraic operation like tambah, tolak, bahagi, darab, multiplication, addition, subtraction, division. We can perform all these algebraic operation to the polynomial just now. Okay, and of course we have laws of numbers like commutative, associative, distributive. Macam you dah belajar in the first chapter, right? Okay, kita tengok addition and subtraction. Macam mana kita perform addition, tambah dan tolak untuk polynomial. So, the addition and subtraction of the polynomial px and qx. Okay, let's say you have 2 polynomials, px, satu px, the other one is qx. Can be performed by collecting similar term. Maksudnya, you kumpulkan term yang sama dalam polynomial tu. Contoh, for example, we have this polynomial px, 2x to the power 4, 5 minus 5x cubed minus 4. And the second polynomial, which is denoted by qx, equal to x to the power 4 plus blah, 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 blah. Okay, so now you have to perform addition. You kena tambah these two polynomials, px plus qx. What happen is that you have to kumpulkan all the similar terms. Apa maksud similar terms? Okay, you refer here. If you have x to the power of 4, tambahkan dengan x to the power of 4. If you have x to the power of 3, you tambahkan dengan x to the power of 3. If you have constant, you tambahkan dengan constant. Macam itulah. Contoh, 2x to the power of 4. Okay, kita write down dulu macam ni. Px plus qx. Tulislah semula. Px dia yang ini. Plus, tulis cantik-cantik. Qx is this one. Okay. Okay, now you can perform your addition. You punya hasil tambah. 2x to the power of 4 plus x to the power of 4. So you have 2 plus 1. So you have 3 lah. Okay, then we have negative 5x cubed. Okay, cari yang kuasa 3 juga. Find the similar term x cubed juga from here. So you have negative 5x cubed plus x cubed. So negative 5 plus 1. So you have negative 4. And how about kuasa 2? So okay, kita tengok, kita susun dia daripada we arrange the sequence from the highest to the lowest power. Okay, for example, you have 4, 3. Jangan lompat terus ikut 4. Cari dulu. 4, 3, 2, 1 to the power of 1 and then the constant. Okay, so you arrange it from the highest to the lowest. Okay, find the similar term for 3x for x squared. You don't have any x squared over here, so just write it down back. 3x squared plus 4x. Also over here you don't have x. Okay, so teruslah tulis plus 4x and negative 4. Okay, sama juga for this one, you don't have any pair over here, tidak ada similar term, so you just write it back, negative 4. So this is the final answer. Senang saja. Easy peasy, kan? Okay, now this is multiplication. Sama jugalah kalau tolak, begitu juga. Kalau ini tambah, so you cari similar term, tambahkan dengan yang similar term. And when you have subtraction, tolak, you cari yang similar term, similar power, you tolak dengan power yang sama. Okay, for multiplication, hasil darab. Every term in one polynomial is multiplied by each term in the other polynomial. Okay, maksudnya setiap term, setiap sebutan dalam satu polynomial tu, kita kena darabkan dengan term yang satu lagi untuk polynomial yang seterusnya. Maksudnya macam ni. You have two polynomials, px and qx. So you have to determine hasil darab, the multiplication of px times qx. So first of all, you need to write it down nicely. Px times qx like this. Okay, tulis macam ni dulu. Then only you can see which one you want to multiply with which term. Okay, now you can multiply x squared times 2x cubed. You have 2x to the power of 5. Okay, next, you multiply this one pula. X squared multiply with x squared. So you have x to the power of 4. Jadi ni nanti you kembangkanlah. You tambah kembang-kembangkan dia. Macam you buat quadratic punya expansion. Pengembangan kuasa kuadratik kan. Sama jugalah. Then you multiply lagi dengan yang ini. Semua ni kena darab satu-satu. Dah selesai, ini yang dah ringkas lah. Dah nicely done. But you have all messy things in between. Meaning you have to find this thing. Okay, this term kali dengan yang ini. This term kali dengan yang ini. Dia serabut sikit lah. Okay, kali ni, and then kali yang ini, sama juga. Yang ini pun sama, dia kena kali juga. Dia kena kali satu-satu. Maksudnya you ada 9 term semuanya. Barulah you selesaikan. Dia jadilah yang ini. Okay. Okay, dekat situ dia kata note that if px is a polynomial of degree m and qx is a polynomial of degree n, then product of px qx is a polynomial of degree m plus n. Maksudnya, kalau px tu, polynomial yang pertama tadi, dia ada degree m. Polynomial kedua, dia ada degree n. So, kalau kamu darabkan kedua-dua polinomial ni, if you multiply both of this polynomial, what you get is the degree will become, the degree for the final product, hasil darab tadi tu adalah m plus n. Ni macam what you have learned in indices dalam index chapter 1, kan? Kalau kuasa dia sama, degree dia sama, bukan degree dia sama. If you have a degree and then you want to multiply that term, so dia akan jadi hasil tambah. Okay. Samalah juga for this polynomial. Okay, when you have multiplication, of course you will have division. Okay, hasil bahagi juga. So how do we divide polynomial? Okay, first of all, the division of the polynomial can be expressed in the form of this. Px equal to dx times qx plus rx. So what is px? Px is your polynomial. Dx over here is your divisor ataupun kita punya pembahagi. Qx is quotient. Quotient ni maksudnya kita punya hasil bahagi itulah. And Rx is the remainder. Baki dia. Kan kalau kita bahagi kan, sometimes we cannot bahagi completely. Dia akan ada baki dekat bawah. That baki is known as remainder ataupun Rx. So, kena ingat this thing. You have to memorize this form. Px equal to dx qx plus rx. Okay, so for polynomial, usually we perform long division ataupun pembahagian panjang macam ni. So what is long division? So for example, you have 35 divided by 2. 35 ni you kena bahagi dengan 2. So without key in or without using calculator, you have to divide this manually. Macam kita belajar during our primary school dulu kan. 35 divided by 2. So 35 divided by 2, you buat cara kuno macam ni lah. Pembahagian panjang kita panggil 35 divided by 2. 2 times 17, then you get 34. You cannot get exactly 2 kali. I know you can have like 17.5, right? But without the decimal, we are not using decimal over here. You kena guna round number ataupun nombor bulat. So, yang paling dekat 2 kali 17. So, you dapat 34. So, you have this baki over here. So, this baki over here, what we call as our remainder, our Rx. And this thing over here is what we call as our quotient. Okay, Q tadi, quotient. And this 2 is our divisor. Kita punya pembahagi. And where is our polynomial? Here is our polynomial. Px, polynomial of constant. Okay. So now you can susun or you can rearrange this thing in the form of this form. Susun like that nicely. 35 equal to dx. What is your dx? Your divisor 2 times qx 17 plus 1. So samalah. Ini kita tulis dalam bentuk yang ini. Okay, that one is using a constant term. Guna nombor, kan? How about the one with power, with degree? You have x to the degree of 2 and so on and so forth. Example, divide 2x squared plus 3x minus 6 by x plus 1. Okay, so you have to use the long division just now. So this is your px. So this thing become your, I'm sorry. Let me erase for a while. So this x plus 1 is your dx. This is your px, your polynomial. So you have to use the long division. It become like this. This is your dx, divisor. This is your quotient. This is qx. This is your Rx. Okay, and this is your dx. So how to perform long division? Okay, kita buat macam ni. X plus 1 kena kali berapa untuk dapat 2x square plus 3x ni. So kita tengok x dulu. X jangan sekali terus dengan x plus 1. You have to look one by one. X time 2x, then you get 2x square. X kali berapa kena dapat 2x square ni? X time 2x, kan? So, kita letaklah x time 2x dekat sini. You dapat 2x square. Okay, done. Then, you have okay, settle about the first term x over here. We move on to the second one, which is the plus 1 over here. Okay, so like I said just now, we go one by one. Daripada x, now we move on to 1 over here. So 1, you have 1 over here, and you already obtained 2x just now. So you multiply this one. 1 times 2x. So you write it down as this one. So dapatlah 1 times 2x, you get 2x. Jadi kita dapatlah yang ini. So sekarang, you tolakkan dia. Minus this one. 2x square minus 2x square, you get 0. 3x minus 2x, you get x over here. Okay? So you dapat x. Ada x dekat sini. Okay, then kita bawa turunlah yang ini, negative 6. Ni bawa turun, ya, negative 6. Okay, sekarang kita settlekan lagi. X kali berapa dapat x? X time 1, you get x. Okay, so you have x time 1, you get x over here. And this one, you multiply again. Yang dah dapat dekat sini, you multiply again dengan yang di sini. 1 times 1, you get 1 over here. So, repeat the same procedure. You have to minus these two. X minus x, you get 0. 6 minus 1, you get minus 7. Negative, negative. So, you get negative 7. So, stop until here because you don't have any more term at the end. So, this is the answer. So, you have quotient, hasil bahagi kita, 2x plus 1, and the remainder, baki dia is negative 7. So, you can write it down back like this, in this form. Tulis mula dalam bentuk yang ini. So, px just now, you have 2x squared plus 3x minus 6. This is, the whole thing is your px, your polynomial, equal to 2x. Okay, you write it down nicely. So, this is 2x. What is your quotient? Your quotient 2x plus 1 times divisor. This is your divisor, x plus 1 minus 7. Because your remainder is negative 7. So, this is actually, yang ini, actually samalah dengan yang ini. Okay, we move on to the more complicated example. X to the power of 4, blah, 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 divide by x plus 1, x plus 3. Okay, what happened is that when you have to divide with quadratic term, macam ni, you have to expand this. Kembangkan yang dua ni. Kembangkan, you have to expand this one. So, what happened? Kembangkanlah dia. X, macam you expand quadratic. X times x, you get x square and so on and so forth, kan? So, you get this one. So, this is actually x plus 1 just now. This is actually x plus 1, x plus 3. Dia adalah benda yang sama yang tadi. The same thing. It's just that I already expanded. Okay. Again, we repeat the long division just now. quite tedious kan? Dia banyak step dia. Okay, x square kali berapa dapat x square seempat? X square time x square. So you dapat x to the power of 4. Okay. Okay, macam yang tadi, saki baki dia you darabkan. Saki baki dia yang belum lagi disentuh ni you darabkan. 4x time x square, you dapatlah 4x cube. Dapat ni. Then 3 time x square, you dapatlah 3x square. Macam tu So I repeat again, yang belum disentuh, yang ini you darabkan dengan yang atas ni. 4x time x square, you get 4x cube. Tu yang dapat dekat sini. Then you have 3 time x square, you get 3x square. Barulah you minus dia. Tolaklah dia. X minus x to the power of 4, kosong. X cube minus 4x cube, you get 3x cube. Ini pun tolak. 0x square minus 3x square, you get negative 3x square. Ni bawa turun. Oops, over pula. Okay, bawa turun yang ni. Also, this one also bawa turun. Okay, then you repeat again the same procedure. X square kali berapa dapat 3x cube? X square kali 3x. Dapatlah, tulislah dekat sini. X square kali 3x. Okay, bermula lagi. Yang ni, yang belum kena sentuh tadi tu, you multiply balik. 4x times 3, negative 3x square, you get negative 2x square. 3 times negative 3x, you get negative 9x. So, bawa turun semua ni. You tolak lagi dia sekali. Okay, tolak lagi. Dapatlah yang ini dan seterusnya. Sampailah yang ini. Yang you dah tidak boleh bahagi lagi kan. So, this one become your Rx. Sorry. This one become your Rx. So, this is your quotient. This is your divisor. So, begitulah. That is what we call as long division. Okay, you have to try it back on your own so that you can memorize the step. Not actually memorize, you can learn faster and you can improve better with the long division. Okay, so we finished the first subtopic. We have 3 more. We have 3 more to go. Okay, let's have 5-minute break.